Welcome back to my channel. In this video we're going to learn the ports on our board and the corresponding pins and the registers that help us control the ports. We have four main general purpose ports: P2, P3, P4. As a notation you can use PX. P1 here, for example, is an example of GPIO ports available on our microcontroller. These ports provide pins that can be configured as inputs or outputs. Port 1 has pins P1.0 to P1.7. For each GPIO port, there are associated control registers, corresponding control registers that configure the port's mode, input or output value, or pull up, pull down resistors, and so on. The main registers used with GPIO ports in our microcontroller are PX registers. Our first register is PX dir, and this X here is a variable, which could be any value from 1 to 4. DIR dir stands for direction. So this is a register that determines whether the pins are configured as inputs or outputs, inputs being zeros, outputs being ones. PX out is, again, the output register for a specific X value from 1 to 4, and it sets the output value of output pins which were previously determined by this dir register, P2 dir. If this X was 2, for example, P2 out would set the output value of output pins which were set by P2 dir. And this PX in, likewise, it is the input register for a specific X value, and this register reads the input value of input pins which were set by PX dir. We also have this register. What it does is it enables or disables the internal pull-up or pull-down resistors for input pins, but we're going to cover this register in its own video. We have this register in front of us. You can see it consists of 8 bits, so imagine it's an 8-bit number. Pin 10 is connected to bit 0, so whenever you make changes on this bit specifically, you're going to have P10 affected. Let's say you want to change P10. What you have to do is you're going to manipulate, you're going to alter the pin here on bit 0. You're going to make this, for example, 1. And when you do that, what you're going to achieve is an output pin. And in order to manipulate certain bits without touching the other bits, we're going to use these 3 operations. This is the assembly form, this is the C form, and this is what they mean in English. This is an OR operation, you can see, and if this is our register, and this is our number we want to do the operation with. And this is the result we have. You can see 0, 0, 1, 0. Whenever I want to set a bit, a certain bit, to 1 in my register, I have to use an OR operation. You can see what this does is it basically sets the second bit to 1 no matter what. This could be 1, I mean initially, and it would still give us 1. We also have a bit clear logic. This is our register, or like this is the value our register holds. This is a sign that indicates AND operation. This is our second number, which we take the complement of. It was previously 0, 1, 0, 0. Now it is 1, 0, 1, 1. So this will like do an AND operation bit by bit. 1 and 1, 0. 1 and 0, 0, so forth, so on. So what this will get us is, you can see I have this bit, the third bit, 1 here. So it's going to take that bit in our register, and it's going to make it 0, no matter what you have initially in your register. This could be a 0 and would still get us 0, 0, and 0, 0. Wouldn't change the result. The last operation we have is XOR operation, and I want you to ignore like these 3 bits, and I want you to focus on the least significant bits. What this operation does is it toggles that certain bit given in your second operand. You can see this is a 1, right? So when you XOR 0 with 1, you're going to end up having 1. And when you XOR 1 with 1, you're going to end up having 0. So now this bit will be toggled in a register if this bit was given here. If this was the third bit in our second number, we're going to have this bit toggle, and the end result then would be, or like would have been 1, 0, 1, 0 instead of 1, 1, 1, 1.